Howdy, students. In the last video, I described how science generates knowledge through a three-step process. The first step is an individual scientist generating and testing hypotheses and reaching conclusions about them. Next, the scientist writes up the details of the experiment and submits it to a journal where it undergoes peer review. Peer review means the paper is evaluated by other experts in the field. If they don't spot any problems, then the paper is published in what we call the peer-reviewed literature. Important conclusions are then retested by the scientific community. So, if you want to know if a claim is supported by science, you should read the peer-reviewed literature. If you find many successful replications and retests of the claims by independent scientific groups, you can have some confidence the claim is true. Exactly how much confidence will depend on the number and stringency of the replications. Make sure you understand this process of establishing scientific truth. It will certainly be on the exam. But while this sounds simple in theory, all you have to do is read the scientific literature. It's actually quite difficult to do in practice. The reason is that the peer-reviewed literature is extremely hard to read. I read papers like this, and I can't make heads or tails of it. And I'm the one who wrote it. Scientific papers tend to be densely written and full of jargon, and it's impractical to expect non-experts to read and evaluate the peer-reviewed literature. So we need a different way of communicating what's in the peer-reviewed literature to policymakers. What we need is a summary of the peer-reviewed literature that is understandable to non-experts. The summary should focus on questions that are important to policymakers. For example, is the Earth warming? Are humans to blame? The report should then summarize what the peer-reviewed literature tells us about each one and how confident we are about that conclusion. Such a summary is known as a scientific assessment. Policymakers can turn to these assessments in order to determine what the science says on any particular scientific claim. Let me emphasize, assessments do not perform new science. Their job is simply to summarize and assess the peer-reviewed literature. Assessments typically begin by assembling a writing team of scientific experts. Having a committee of scientists writing the report is important because it reduces the possibility that the erroneous opinion of a single biased individual makes it into the report. This is exactly what you do in a high-stakes medical decision. If you go to a doctor and he says, "We're going to have to cut off your arm," you wouldn't say, "Great, start cutting." You'd get multiple opinions to verify that's actually the right diagnosis. You do this to reduce the chance of a single bad doctor giving you terrible advice. If you had the time, money, and patience, you'd like to assemble a group of some of the world's experts on your medical condition to evaluate your case and give you their diagnosis. If they all agreed, you could be confident this was the best advice that modern medicine could give you. This is essentially what a scientific assessment does. The writing team is made up of the world's experts, and they write an assessment about what the peer-reviewed literature says about the question in front of them. To the extent that they agree, their opinion is really the best opinion that science can provide on a scientific claim. As an additional check on the assessment, the final version is itself peer-reviewed, meaning it's sent to other experts to ensure that it reflects the underlying peer-reviewed literature. There have been many assessments of the science of climate change. The most well-known are done by the Intergovernmental Panel on Climate Change, known by its initials IPCC. Founded in 1988, as nations began to acknowledge the seriousness of the climate problem, the IPCC writes comprehensive reports every 6 or 7 years that summarize what we know about climate and how confidently we know it. The IPCC makes enormous efforts to get the most unbiased assessments of the science, and because of that, IPCC reports are widely regarded as the most authoritative statement of scientific knowledge about climate change. Reflecting this, the IPCC shared the 2007 Nobel Peace Prize in recognition of its work assessing climate science. However, because of its high profile in the climate debate, policy actors have expended a lot of effort trying to discredit the IPCC. Therefore, it's important to point out that the IPCC's assessments do not stand alone. There have been many other assessments written by other credible organizations that reach the same conclusions. The U.S. National Academy of Sciences is one such organization. It was set up by Abraham Lincoln specifically to answer difficult science questions for the nation. It has also put out assessments that agree with the IPCC's. So has the UK Royal Society. NASA, NOAA, and the National Science Foundation are all on record agreeing with the IPCC's conclusions. Scientific organizations like the American Meteorological Society also have statements in agreement with the IPCC's conclusions. It would require a conspiracy of ridiculous proportions to believe that all of these groups are lying in order to advance some political agenda. So I can now answer the question I posed at the beginning of video 3. In this video, I'll address an issue that generally does not come up in college courses: why you should believe your professor. The answer is that almost everything in this course is based on assessments from the IPCC and other credible assessment bodies, which in turn are based on the peer-reviewed literature. What you're going to hear in this course is not just my opinion of what the science tells us. It's the opinion of the entire scientific community. This brings us to the tricky subject of ways not to determine what to think about the science of climate change. First, your friends and family are not good sources of information. They might mean well and be terrific people, but they haven't read all the peer-reviewed literature, and they probably don't know what they're talking about. In the unlikely event that one of your relatives or friends happens to be a climate scientist, you still should not rely on them. Any single person, no matter how well-meaning or how much you trust them, may be biased or be mistaken. The odds of a large group of scientists writing an assessment being biased or mistaken, however, are much, much lower. So you should stick with assessments. That goes for me too. Don't believe me because I'm on the faculty of the best university in the world, or because I'm extremely witty. Believe me because what I'm telling you is based on scientific assessments. Also, be very careful searching for the internet for information. You can find any answer you want out there. Climate change is a hoax, vaccines cause autism, the earth is flat, moon landings were a hoax. That's not to say there aren't some good sites out there. There are, and here's one I recommend for getting your climate information. But it's difficult to determine what's credible and what isn't because you don't know where any particular internet source is getting their information. That's why you all should rely on assessments too, and that's why you can believe what's in this class. And now, your moment of dog.